Hello everyone. The topic that we are going to report is all about limits. History of limits. Ancient Greek mathematician Archimedes of Syracuse, 287 to 212 BC, first developed the idea of limits to measure curved figures and the volume of sphere in the 3rd century BC. By carving these figures into small pieces that can be approximated, then increasing the number of the pieces can give the desired quantity. Limits. In mathematics, a limit is the value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematical analysis and are used to define continuity, derivatives, and integrals. Theorem 1 limit laws. If L and M and C and K are real numbers and limits x approximated of C, f of x equals to L, and limits of x approximated C, g of x is equals to m. Then, the sum rule is limits of x approximated C, f of x plus g of x is equals to L plus m. And difference rule, limits of x approximated of C, f of x minus g of x is equals to L minus m. And constant multiple rule, limits of x approximated of C, k times f of x is equals to k times L. In product rule, limits of x approximated C, f of x times g of x is equals to L times m. Quotient rule, limits of x approximated of C, f of x over g of x is equals to L over m not equal to 0. Power rule, limits of x approximated of C, f of x to the power of n is equals to L to the power of n a positive integer. Root rule, limits of x approximated of C, n square root of f of x equals n square root of L is equals to L to the power of 1 over n a positive integer. If n is even, we assume that limits of x approximated C, f of x is equals to L greater than 0. Example number 1. Limits of x approximated to x squared plus 6x plus 8 over x plus 4. Limits x approximated to, factor out the x squared plus 6x plus 8, so that's why the x plus 4 times x plus 2 over x plus 4. So cancel out the x plus 4. So limits of x approximated of 2 x plus 2. Substitute the value of x into that 2. So that's why 2 plus 2 is equals to 4. As x approaches 2, 4 is the limit. Example number 2. Limits of x approximated of negative 3, x squared plus 6x plus 8 over x squared plus 6x plus 6 is equals to limits of x approximated of negative 3, factor out the x squared plus 6x plus 8. So that's why x plus 4 times x plus 2 and factor out the x squared plus 6x plus 6. So that's why over x plus 3 times x plus 2. So cancel out the x plus 2. So ang nabilin is limits of x approximated of negative 3, x plus 4 over x plus 3. So the limits of x negative 3, substitute the value of x. So into negative 3. So negative 3 plus 4 over negative 3 plus 3 is equals to negative 1 over 0. Therefore, the limit does not exist. Example number 3. This is the example of one-sided limit. If the given is f of x is equals to x squared if x less than equal 3 and 2x if x greater than 3. So find the limits of x approximated of 3 positive. F of x is equals to limits of x approximated of 3 positive. F of x is equals to limits of x approximated of 3 positive 2x. So substitute the value of x into positive 3. So 2 times 3 is equals to 6. So find the limits of x approximated of 3 negative f of x. So limits of x approximated of 3 negative f of x is equals to limits of x approximated of 3 negative. So substitute the value again the x, so negative 3 squared is equals to 9. So limits of x approximated of 3 positive f of x is not equal to limits of x approximated of 3 negative f of x, and therefore limits of x approximated 3 f of x does not exist. So example number 4. Find limits of x approximated of negative 2 positive x over x plus 2. So first we try plugging into negative 2 positive in 4x. So f of negative 2 positive is equals to negative 2 positive over negative 2 positive plus 2. So equals negative 2 positive over 0 positive, because a number just to the right of negative 2 has a magnitude that is a bit smaller than negative 2. And so adding this number to positive 2 will give us a number just a little bit larger than 0. So negative 2 positive over 0 positive is equals to negative infinity. This value is negative because we are dividing a negative value by a positive 1. So the limits of x approximated of negative 2 positive x over x plus 2 is equals to negative infinity. Example number 5. Find limits of x approximated of 0. X squared over square root of x plus 1 negative 1 is equals to limits of x approximated of 0. X squared over square root of x plus 1 negative 1 minus 1 times the quantity of square root x plus 1 over square root of x plus 1 plus 1. So we try multiply the top and the bottom of the fraction by the conjugate of the bottom. Since the bottom contains a radical, we choose to do this because this will help us to eliminate the radical in the bottom, although it will add a new radical to the top. So that's why. So equals limits of x approximated of 0, x squared times square root of x plus 1 over x plus 1 minus 1. By performing the multiplication yields this expression. So it's equals to limits of x approximated of 0, x squared times square root of x plus 1 over x. By simplifying the bottom yields this expression. So it's equals limits of x approximated of 0, x square root of x plus 1 by cancelling 1x out of the top and the bottom yields this expression. So substituting 0 into this new rewritten version of f of x and simplifying yields the limit of 0. So 0 times square root of 0 plus 1 equals to 0. Square root of 1 plus 1 equals 0 times 1 plus 1 is equals to 0 times 2 is equals to 0. So that's all. Thank you.